So now we are going to see decimal to octal conversion and the vice versa. This is our second example in number conversion. For the same number I'm going to take and I'm going to convert into octal. So first take the whole number part, that is before the decimal point, and do the same L division method for converting the decimal number into some other radix. So here our radix is 8, so I'm going to divide it by 8. So 3 and the remainder is 1. And go to the decimal part now. So in decimal part, what is our decimal part? 0.75. So you usually for converting the decimal number into a particular radix, we are going to multiply the radix, but in 8 to the power minus 1 form, and after that 8 to the power minus 2. So first 0.75 into 8 to the power minus 1 is 0.875. Then you have to take only the decimal part. So 0.875 into 8 to the power minus 2. So this is 0.875 divided by 64. So if you do 0.875 divided by 64, you will be getting 0.78125. And you have to add this. If you add this, you will be getting 0.953125. So now we have converted the given decimal number into octal number. As a result, we got 31.953125 base 8. Now let us move for the vice versa part. That vice versa part is that is from the octal number to decimal number. The octal number to decimal number. So here what octal number we got for 25.75? The octal number we got as 31.953125 base 8. So now we are going to convert this into decimal part. So the same logic was we did in binary binary to decimal conversion. The same logic we are going to apply. So 31 for decimal conversion, 1 into 8 to the power 0 equal to 1, and 3 into 8 to the power 1 equal to 24. You got 25. So for 31 octal, equivalent decimal is 25. So now let us move for the fractional part, that is 0.953125. So this for 0.953125, what we are going to do? We are going to just multiply it by 8. So if you are multiplying it by 8, you will be getting the result as 7.625. Don't consider the whole number, just consider the fractional part, that is 0.625. Multiply it by 8 and you will be getting the result as 5.0. So if we got this 0.0 after the decimal point, if we got 0.0, and we are going to stop the multiplication. If we didn't get the after decimal point, if we didn't get 0, we are going to continue for 5 or 6 times. So after 5 or 6 times, you can stop and you can write the whole part alone. So now the equivalent now the equivalent decimal conversion, what we got for 31 we got 25, and for 0.953125 we got 75. So this is our equivalent decimal conversion. So now let us move for the another example. So another example is that is octal hexa conversion. The hexa conversion for I'm taking another example for hexa conversion. So hexa conversion is the hexa conversion. I'm going to take one example, 30.75 base 10. I'm going to convert this into hexa. The same logic we are going to take. First take the whole number, 30 divided by 16, quotient 1, and remainder is 14, and the equivalent hexa is 1e. And for dot 75, how we are going to do the dot 75? That is 7 into 16 to the power minus 1. 7 into 16 to the power minus 1 will gives you dot 4375, and 5 into 16 to the power minus 2, that is nothing but 5 divided by 256. This will gives you 0.01953, and if you add, you will be getting the result as 45703. So now the equivalent hexa is 1E dot 45703 base 60. So now let us move for the vice versa part, that is from hexa to decimal conversion. So we got the hexa value as 1E dot 45703 base 16, and I'm going to convert this into decimal. So how I'm going to convert this into decimal? 1E, E into 16 to the power 0 equal to 14, and 1 into 16 to the power 1 equal to 16, and the equivalent value is 30. And for decimal part, how we are going to convert into decimal part? So dot 45703 into 16, you will be getting the result as 7.31248. Then take only the decimal part alone, the dot 31248 into 16 equal to 5.0. So after the decimal point we got 0, so we are going to stop our multiplication here, because if you are going to do dot 0 into 16, again you will be getting dot 0. So just we are going to stop there, and the equivalent decimal part is, what we got is 30.75 base 10. So that's it. Our videos come today. The number conversion, all three conversion we did. That is from decimal to binary, and vice versa, and decimal to octal, hexa, as well as the vice versa. Thank you, students.